All right, everybody. This video talks about the laws of logarithms. And basically, we're going to use these laws of logarithms extensively in this class. We use it to help us take derivatives, and we're also going to use this to help us calculate limits. So we will use these laws to take derivatives. That technique is called logarithmic differentiation. So called logarithmic differentiation. And we're also going to use it to calculate limits. And we're going to learn something called L'Hopital's rule. So I'm just going to abbreviate it with LH. So those are going to be discussed in the near future for us. Um, what we're going to do is we're going to start off saying that we have two numbers. And what logarithms tells us is logarithms tells us that we can write each of these two numbers with respect to a base. So I could say like um, m would be equal to something like b to the u. In other words, I could take any positive number m and rewrite it as b to some power, and u is whatever power makes that work. And n is going to be similar. We're going to call that n is equal to b to the v power. So just as a quick example, um, let's say that we looked at the graph of our original function over here. If you were to try to grab, I don't know, m was equal to 6, if m is equal to 6, that's the same thing as 2 to some power. That's 2 to some number between 2 and 3, whatever this x value is, that would be what the power would be. An easier example would be something like if m was equal to 8, then what power do I raise 2 by to get 8? Well, I'd have to raise it to the third power. Okay. So in that case, u would be 3. So let's go back to this here. So again, for example, if I had 8, that's the same thing as 2 to the 3. That means your m value is equal to 8, your b value is equal to 2, and your u was equal to 3 in this particular case. Okay, so we could do that for any positive number. Um, and earlier we had seen that there were three laws of logarithms. So there's the product rule, which says if you have two numbers and you multiply them together and you want to know what's the exponent will be obtained by just adding the exponent that comes from m and the exponent that comes from n. Okay, so this is the product law. So why don't we kind of write out why the product law works so that you can see that. So let's say that we started off with this product, mn, right? So we know that m can be written as b to the u, and n can be written as b to the v. And so we know that when I multiply this product together, I'm really multiplying these two numbers together. But from the exponential laws, I know how to multiply two things together with the same base. Two things together with the same base, you're going to add those powers together. So this would give you b to the u plus v, right? So if I were to take this line and then take logarithms of this whole thing, I would have log of this guy, I'd have log base b of b to the u times b to the v, like that. That's sort of taking log of this piece. And when I take log of this piece, what am I going to get? Well, when I take the log of this piece, here's where I utilize the fact that, when you have log base b of b to something up here, you just get the original thing back, right? And that's because the exponential function and the logarithm are inverses of each other. So when we take log of this expression right here, I'm just going to get u plus v back. Well, what was u plus v? U plus v was log base b of m. So, right, that's the logarithmic version of this equation. And log base b of n is the logarithmic version of this equation. So that sort of justifies the product rule. Okay. So using a similar line of argument, we can also get the quotient rule. In other words, if you have a quotient of two numbers, what are you going to do there? You're going to write each of these as b to some power. This would be b to the u divided by b to the v. And then you know that when you have two things with the same base subtracted from each other, right? Like if you have b to the u divided by b to the v, that means you just subtract the exponents. And when you subtract the exponents are these logarithms. So that's how you get the right-hand side of this equation, right? This last one is really a power to a power. So we call this the power law. If you had something like b to the u all raised to the r power, what do? You're going to multiply the exponents together. So that gives you b to the u times r. And you know that this piece right here is just u. So the whole exponent just becomes u times r. And you can see that right here. All right. So these are the three laws of logarithms. They're super important for this class, and we use them to do logarithmic differentiation and to execute L'Hopital's rule. Some of the problems in L'Hopital's rule, there's something called indeterminate powers, and that's where we're going to use the laws of logarithms there. So we'll look at some examples in class, and I will see you folks soon.